Hello. Today we're covering something that sits underneath every single survey ever run: sampling and sample size. How many people do you actually need to survey? And does it matter who you pick? The answers are more interesting than you'd expect, and getting them wrong is one of the most common and most invisible mistakes in all of market research. Let's start with the problem. Here's the core challenge. You almost never have the time, money, or access to survey everyone in your target market. So you survey a smaller group instead. But that raises two questions immediately. How many people is enough? And does it matter how you pick them? The answer to both is yes. More than most people realize. Survey too few people and your results are unreliable. Survey the wrong people and your results are misleading. And here's the dangerous part. Both mistakes look identical on a spreadsheet. The numbers come out looking perfectly normal either way. The good news is that sampling works. A small, well-chosen group really can represent a much larger one. And that's not magic, it's math. But those two words, well-chosen, are doing a lot of work. A poorly drawn sample misleads you no matter how large it is. You could survey 10,000 people and still get the wrong answer if you pick them badly. Size matters, but who you pick matters just as much. So what is sampling formally? It's the process of selecting a smaller group from your target population to survey, so you can draw conclusions about the whole without talking to everyone. That's the whole idea. And the remarkable thing is that it actually works. A well-drawn sample of around 400 people can give you results accurate to within a few percentage points for a market of millions. The key phrase there is well drawn. Let's talk about what that means. Two terms you'll use constantly. The population is everyone you want to understand. Say, all the gym goers in the United States. That could be tens of millions of people. The sample is the smaller group you actually survey, maybe 400 of them. You learn things from the sample that draw conclusions about the population. That leap from sample to population is only valid if the sample actually reflects the population. If it doesn't, your conclusions are about your sample, not your market. Let's make this concrete. Pulse app is a fitness app thinking about launching a new sleep tracking feature. Before they build it, they want to know if gym goers actually want it. Their population? US adults who visit a gym or fitness studio at least twice a week. They obviously can't survey all of them. So the question is, how do they pick the right sample? That's what the next several slides are going to walk through, step by step. Step 1. Before you select a single respondent, be exact about who you're studying. Gym goers is too vague. US adults aged 18 to 55 who visit a gym or fitness studio at least twice a week is a population you can actually sample from. And there are 3 dimensions you need to nail down. First, who they are, the behavioral and attitudinal criteria that define your target. Second, where they are. Geography shapes your population in ways that matter. A national survey and a Miami survey are studying very different groups of people. And third, what they look like demographically. The racial, ethnic, age, and gender profile of your population varies significantly by location. You can't build a representative sample until you know the actual makeup of the population you're studying. Step 2 is the golden rule. Give everyone in your target population a genuine chance of being selected. That's what random sampling means in practice. If your sample isn't random, it's biased, and your results will reflect that bias rather than the real population. Here's how it goes wrong most often. You survey only people on your email list, but those are already your most engaged customers, not a representative cross-section. You only ask people who are actively using your app. The active users are a very different group from your broader market. Or you only survey in one city when your population is national. Any of these shortcuts introduce bias, and the numbers come out looking perfectly normal even when they're wrong. There are 4 common approaches. Simple random sampling is the purest form. Every person in the population is equally likely to be selected. Stratified sampling divides the population into groups by geography, age, race, gender, and then samples from each group proportionally. This is the most reliable tool for getting demographic representation right. Systematic sampling takes every nth person from a list. Practical and often good enough for many research situations. And convenience sampling surveys whoever is easiest to reach. It's fast, but it's risky, because easy to reach and representative are rarely the same thing. For most serious research, stratified sampling is the approach that best ensures your sample actually mirrors your population. Here's a concept that most survey reports mention and most readers ignore, and that's a mistake. Every survey results comes with a built-in uncertainty range called the margin of error. Let's use PulseApp. Say 58% of respondents say they want the sleep tracking feature with a margin of error of plus or minus 4%. That means the true answer in the real population is somewhere between 54% and 62%. That's a wide range, wide enough to matter for a product decision. Most people report the 58% and forget the range entirely, but the margin of error is just as important as the result itself. Always report them together. Related to margin of error is the confidence level. How certain you want to be that your result actually falls within that range. The standard in most research is 95% confidence. In plain English, that means if you ran the same survey 100 times, 95 of them would produce a result within the margin of error. The remaining 5 might land outside it by chance. A higher confidence level, say 99%, requires a larger sample because you're demanding more certainty. A lower level, like 90%, needs fewer people but gives you less assurance. For most research, 95% is the default, and it's where you should start unless you have a specific reason to go higher or lower. So how do you actually calculate how many people you need? 3 inputs go in. Your confidence level, almost always 95%, your margin of error, how much uncertainty you can tolerate, usually plus or minus 5% for general market research, and population variability, how different people's answers are likely to be from each other's. When variability is unknown, researchers assume maximum variability, which produces the most conservative and safe sample size. You don't need to do this math by hand. There are free online calculators that handle it in seconds. But you do need to understand what you're inputting so you get a number that actually fits your research. Here's the most practically useful thing in this entire video, the sample size curve. As you increase the number of respondents, accuracy improves rapidly at first. Going from 50 to 100 to 200 respondents makes a dramatic difference. By the time you reach around 385 people, you're hitting plus or minus 5% margin of error at 95% confidence. And here's the part that surprises most people. After 400, the curve flattens. Going from 400 to 4,000 respondents barely improves your accuracy at all. The math of sampling has diminishing returns built in. That's why most general market survey target 385 to 400 respondents. Not because it's a tradition, but because it's the point where adding more people stops buying you meaningful accuracy. Spend extra budget on better questions and better sampling, not more volume. This is one of the most important distinctions in this whole video, and it's one the research industry gets wrong more often than it should. A representative sample is not an even split. It's a proportional one. If you're surveying gym goers in Miami, and the actual population of Miami is 70% Hispanic and skews younger, then your sample should be approximately 70% Hispanic and age-weighted to reflect that reality. An artificially balanced sample, say 25% each across 4 ethnic groups, would actually be less accurate because it no longer mirrors who's really in your population. The goal is always to reflect the real demographic makeup of the specific geography and population you're studying. After you collect your data, check your sample's actual breakdown by gender, age, race, and ethnicity against the real population and adjust through weighting or re-quota if it's off. Here's where a lot of researchers get caught out. Your overall sample size might be perfectly adequate for headline results, but if you want to compare results across different groups, each group needs to be large enough on its own. A total sample of 400 split across 4 U.S. regions gives you only 100 per region, which is workable but thin. If one demographic group makes up only 8% of your sample, that's 32 out of 400. Far too few to draw any reliable conclusions about that group specifically. The rule of thumb, if you plan to analyze a subgroup separately, the subgroup needs to be 300 to 400 of its own responses. For PulseApp, if they want to compare results across 4 regions, they need 300 to 400 per region, which means a total sample closer to 1200 to 1600, not 400. Even with the right sample size, 4 common biases can quietly corrupt your results. Self-selection bias, only the most motivated people respond, typically your most engaged fans or your most frustrated detractors, not the average customer. Convenience bias, you survey whoever is easiest to reach, which is almost never a representative cross-section. Survivorship bias, you only survey current customers and miss the ones who left, but the people who churned often have the most useful things to tell you. And non-response bias, the people who don't respond to your survey are often systematically different from those who do. Silence isn't random. Each of these can make a perfectly sized sample produce completely wrong conclusions, which is why sampling methodology matters as much as sample size. 7 things to take away with you. Define your population precisely. That means geography and demographics, not just behavior. Sample randomly so every person has a genuine chance of being included. Use stratified sampling to hit proportional demographic representation. Match your sample to the actual makeup of your population, not an artificial even split. Always report your margin of error alongside a result. They go together. For most general surveys, around 385 to 400 respondents gets you plus or minus 5% and 95% confidence. Beyond 400, more people gives you very little extra accuracy. Spend that budget on better sampling instead. And watch for sampling bias, because it can mislead you completely regardless of how many people you surveyed. Get the sampling right, and every result you produce becomes something you can actually trust. Thank you for watching.